Today we'll see about general construction of ellipse. This method also called as eccentricity method and general method of constructing of ellipse. Here we mention the distance from focus to directrix is 50 mm and eccentricity is 2 by 3 he mentioned as 2 by 3. That means distance of point from focus to distance of point from directrix. This is known as eccentricity, that is distance of point from focus to distance of point from directrix. So here we'll see about the construction of ellipse now. First we need to write a directrix line. It is a straight vertical line that we need to write aside. Here I am giving this as D and D dash. This is your directrix line as well as fixed straight line. And next, perpendicular to this we have a principal axis called as AB. A and B. This is a principal axis that we called in construction of ellipse. After these two lines, directrix line and fixed straight principal axis, here we need to locate focus. Here focus distance is mentioned in a question itself, that is focus to directrix distance is 50 mm is mentioned, 50 mm. So that here this is your directrix line. From this on the principal axis, see here I am keeping it, see, measure 50 mm means at 5 centimeters. See here, this is your focus. Here locate focus of 50 mm distance from its directrix line and locate it as F. Then after, divide this AF distance into 5 equal parts. Here we have 50, each part containing 10. 1, 2, 3, 4 and 5. Here like this, divide this into 5 equal number of parts, then give this as 1, 2, 3 and 4, again 5 here we have. Then after locating focus point, we need to locate the vertex point. Vertex point is nothing but a starting point of your ellipse curve. Here for that, here we need to use eccentricity. Eccentricity mentioned 2 by 3. From focus it is 2 is saying, from directrix it is 3 is saying. So here we have focus, from focus 2. So 1 division, 2 division. So here is the point. Locate a point at 3 first. Next, from directrix he mentioned 3. That is 1, 2 and 3. So this is your vertex. V1 I am indicating it with the V1. Next, from this V1, draw a straight vertical line which is parallel to your directrix. Like this. Okay. Here then after, here measure V1 to F distance. Measure V1 F distance and that is going to be 20 mm as per here divisions. See, V1 F distance, then from V1 as center, mark the distance on that particular line. On the particular line as by using 20 mm. Here see, I am keeping it with 20 mm. See, exactly it is 20 mm. See if you observe this. So at this point, this is going to be P, I am locating it. This point is P, I am locating. See, after locating P point, here we need to use a 45 degrees of inclination in order to locate end point of the curve. Before that, we will join this A, P lines by using a scale. Here by joining these A point, P point, try to make a straight vertical line like this. See, or like this you have to extend a line by joining A and P. Then after we need to locate V2 point. For that, here from V1, take 45 degrees of inclination here. See, this is your point V1. From here locate a point of 45 degrees of inclination. Here it is. No. Next, in order to locate end point V2, here from focus we need to use 45 degrees of inclination. See, this is your point, focus point. From here I am keeping a protractor. See, locate a point for 45 degrees of inclination. See, after locating that, here by using a scale, by using a scale, draw a line like this in order to intersect the first line which is passing through this point. So now you will get an intersecting point. Here it is. I am locating it as P1. See, next from P1 here draw a straight vertical line towards the principal axis, like this, towards the principal axis, and here on line AB you will get another intersecting points. Take it as V2. See, now we have V1, V2. This is V1, V2 is going to be your major axis. Major axis is V1, V2, and AB is the principal axis. Next, measure the distance between V1, V2, and here I am measuring it. See, here I have 90 mm in between V1, V2. Now, here divide this into some equal number of parts. See, here I have 90 mm, so I am dividing this into 9 equal number of parts. See, by keeping each part as 10 mm, here as 1, 2, 3, 4, like this we need to divide this into some equal number of parts. Then after, here I am locating this as 1 and 2, 3, 4, 5, 6, 7, 8. See, like this we need to mark the numbering. Then from each and every equal division, here I mentioned, from each and every division, here we need to write straight vertical lines. See, each and every vertical line need to be parallel with the line which is passing from V1. Each and every line should be parallel to each other. Now here, see, then this is a 1, 2, 3, 4, 5, 6, 7, 8 that we have on principal axis as well as major axis to V1, V2. Then after, here the line which is passing through AP point, see, here locate on this point as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, and 8 dash. Like this, mark the dashed ones, 1 to 1 dash, 2 to 2 dash, like that, so on. Next, take your compass. Now take the compass here. By using this, first we need to take the measurement of 1 to 1 dash, 1 to 1 dash distance and compass, and focus as center. Focus as center, focus as center, 1 to 1 dash distance and compass. See, here it is. Draw arc here on the first line, here above and below of the first line. Here we need to mark 2 arcs. Then here 2 to 2 dash distance and compass, 2 to 2 dash distance and compass. Same focus as center, draw arc here 2 sides of the line. Next, here 3 to 3 dash distance, 3 to 3 dash distance and compass, and focus as center. Focus as center, draw arc here on the third line as well. See, here it is. Like this, similarly, we need to use all the distances. Now 4 to 4 dash distance and compass, focus as center. Focus as center, arc here and here towards up and as well as down. Next, 5 to 5 dash as distance and compass, and focus as center, arc here on the 5th line. Next, 6 to 6 dash. Same focus as center, arc on the 6th line, as well. Similarly, 7 to 7 dash, 8 to 8 dash, we need to mark arcs. Like this, you will get arcs here on the line. Each and every line you will get like this. Now, here, join all these arcs by using your free hand. See, I am joining here. V1 is the starting point. Here, by using a starting point, here by joining all the arcs. See, V2 is the end. We need to end here as V2. Then you see, like this we need to join all the arcs. This is going to be your ellipse. Here this is P1, P2, P3 and P4, P5, P6, P7, P8 and P9, P10, like this. Locate the points on the ellipse curve itself. This is going to be a curve of ellipse by using a general eccentricity method, as well as eccentricity method. Here this is your ellipse. Like this we need to plot our ellipse by using eccentricity is 2/3 and the distance from focus to directrix is 50 mm.